Arithmetic.com.
Next, we are going to check the decimal form of a fraction is terminating or non-terminating. Without actual division, we have to check. The question is, without actually performing the long division, without actually performing the long division, state whether the following rational numbers, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion, or a repeating decimal expansion. This is the question. First one is 13 divided by 3125. Second one is 17 by 8. Third one 64 divided by 455. Fourth one 15 divided by 1600. Fifth one 29 divided by 343. Sixth one 6 divided by 15. We are going to check without performing the actual division. For the first fraction, we have to take the denominator. It is 3125 and find the prime factorization. 3125. We can divide it by 5. 6 5s are 30, remainder 1 12. 5 2s are 10, again remainder 2 25, 5 5s are 25. Again we can divide it by 5, 125, again by 5, 25, 5, 5, which is equal to 5 into 5 into 5 into 5 into 5. That means 5 raised to 5. This is equal to 13 divided by 5 raised to 5. That is the prime factorization of the denominator contains only the prime 5. Therefore, the decimal form or decimal expansion will be terminating the denominator, the prime factorization. The prime factorization of the denominator contains only the prime 5. Contains only the prime 5. Therefore, the decimal expansion will be terminating. Therefore, the decimal expansion will be terminating. This is the method of finding without actual division. The decimal expansion is terminating or non-terminating. Next one is 17 by 8. We have to take the denominator 8 and the prime factorization is 2 into 2 into 2. Since it is a small number, we can find the factorization mentally. That is 17 divided by 8 means 2 cube. Here the prime factorization of the denominator. The prime factorization of the denominator contains only the prime 2. Therefore, the decimal expansion will be terminating. Therefore, the decimal expansion will be terminating. That means after decimal, one or two places the decimal will be stopped. Now the third one is 64 divided by 455. We have to find the prime factorization of the denominator 455. 455, we can divide it by 5. 8 5s are 40, 9 5s are 45 and 5 1 is 5. Then we can divide it by 7, 13. There are two primes other than 2 and 5 which are 7 and 13. Therefore, the decimal expansion will be non-terminating, repeating. It is 5 into 7 into 13. 5 into 7 into 13. That means the prime factorization of the denominator contains primes other than 2 and 5. Primes other than 2 and 5, which are 7 and 13. Therefore, the decimal expansion will be non-terminating. Repeating. The decimal expansion will be non-terminating and it will be repeating also. Now, next one, 15 divided by 1600. We can split 15 as 3 into 5 and here also we can split 1600 into, we are dividing it by 5, it is 5 into 5 3s are 15, remainder 1, 5, 2, then 320. This 5 and 5 getting cancelled, which is equal to 3 divided by 320. 3 divided by 320, therefore the denominator is 320. We can prime factorize 320. Dividing 320 by 2, 160. Again by 2, it is 80. 2, 40. Again 2, 20. Again 2, 10. 2, 5. It is 2 raised to 6 into 5. 3 divided by 2 raised to 6 into 5 is the prime factorization. That means the prime factorization of the denominator contains only the primes 2 and 5. Only the primes 2 and 5. Therefore, the decimal expansion will be terminating. Therefore, the decimal expansion will be terminating. Next one is 29 divided by 343. The prime factorization of 343 is 7 into 7 into 7. That means 7 cube is 343. Therefore, the prime factorization is 29 divided by 7 raised to 3 implies the prime factorization of the denominator. Prime factorization of the denominator contains a prime other than 2 and 5 7 is the prime other than 2 and 5. Therefore, the decimal expansion will be non-terminating repeating. Will be non-terminating repeating. Then the last one is 6 divided by 15. 6 is equal to 3 into 2 and 15 is equal to 3 into 5. This 3 and 3 are get cancelled. Then the remaining is 2 by 5. The decimal expansion will be terminating because the denominator contains the prime only 5. The decimal expansion will be terminating because the denominator contains only the prime 5, because the denominator contains only the prime 5. Now I think you can find the decimal expansion, whether it is terminating or non-terminating, by the prime factorization of the denominator. Without actual division, you can find whether it is terminating or non-terminating. You must understand the method of finding the prime factorization. The prime factorization should contain only 2 and 5, either 2 or 5 or both 2 and 5, then it will be terminating. If there exists any other prime than 2 and 5, the decimal expansion will be non-terminating repeating. Okay.